Good morning, good evening, good afternoon to people around the world. This is Martin Hewell, your host of the DB2 Night Show, and we're up to show number 255. Who knew? Who knew it would last that long? And today our special guest is once again Dale McGinnis of the IBM Toronto Lab up here in Markham, just outside of Toronto, actually. How are you today, Dale?
I'm awesome, sir. Yourself?
I'm doing okay. I'm struggling with these tree-borne allergens at this time of year. I've been more under the weather than I have been for quite a while, but hopefully that'll improve and it'll get back to normal soon. I better be normal by this evening because I got a big dress rehearsal tonight and a big performance on the weekend, so I got to get better. Okay, with that in mind, let's carry on and we'll get the formalities out of the way here. As per normal, we have the Twitter handle of DB2Night, hashtag DB2Night, and our replays are now available on YouTube, and I announce those via Twitter as well. There's our copyright stuff, and we respect people's copyrights. We're recording the show, and beyond that, that basically says basically what it says. So with that in mind, carrying on to the quick announcements. The last show of this year will be Callisto Zuzart speaking on machine learning, the machine learning optimizer in DB2. We've had a little bit on that earlier, but when we did John Hornibrook's session earlier this spring, it appeared a refresher and an update on that content would be valuable. So Callisto is going to join us for that. Also, next week, fitting in around iDoug, we're having the Z show 1 week after this one. Dave Belke is coming back. He's now been elevated to IBM Lifetime Champion, which is a great thing. I hold that title myself. It just means that Dave has been serving the community pretty much for his entire working career with DB2, and IBM has recognized him for doing that. And he'll be talking on Java performance with DB2. And our last Z show will be Soumya Kameswaran of IBM Silicon Valley, and she'll be talking on the DB2 user experience transformation strategy, which is another fancy way of saying it's an application development update. Okay, moving along. As always, our founding sponsor of the DB2 Night Show is DBI Software, and we like to give them a plug for their a demo of their tools. If you're a DB2 LUW person and have need for top performance, you can watch their demo here, and they also now support SQL Server as well as DB2. Our winner from last show is Kevin Nadeau of Cigna. Congratulations, you've got an Amazon gift certificate. Oops. And there's our sponsors again, just yours truly and DBI. And we're into our polls. And if you tuned in just a little while ago, you saw Dale and I fine-tuning these. And here's our first poll. Which DB2 versions are you currently running? Nope, looking good so far. People seem to be pretty up to date. Give you a few more seconds there and we'll close that off. We've got 80% of our audience have voted, so we'll close that off and share the result. Most people are 11.55 or newer. That's great news.
That's awesome.
Yeah. And we'll hide that. If you hear any whining, that's Lacey, one of our two co-hosts of the DB2 Night Show. She is determined that it is time for yet another cookie. You've had 55 cookies today, you know. I just want you to know that. I don't think you need another cookie. But you know, if you whine enough, I'll give you one. So you've got a plan. All right, let's close that off again. Share that result. We got the collector's series out there in terms of commercial DBMSs. That's
Right.
pretty much what we expect these days. And open source. This kind of reads like a what's the up and coming stuff, and I probably could have had a couple of others in there, but the go to webinar polling it only allows 10 answers or 5 answers, so that's what we chose. We chose some of the more popular ones, we think, and that's what we got.
Yeah, I'm seeing a lot of EDB showing up recently.
Okay.
Yeah. Enterprise database is another one that's gaining popularity.
All right, let's share what our audience put down. Redis is the lowest, and MySQL is the highest. That's not a surprise, really. Postgres and Mongo in there, and Maria. Maybe we'll replace Maria with EDB for the next time we ask that question. All right. Now we'll talk about the show a little bit. What's your requirement for availability? I remember going to England a long time ago, but the guy had done a really great job of putting together a disaster recovery plan, and he tested it thoroughly, and it worked beautifully. And after he showed it to me, I said, "That's great. What do your users think? What's your requirement?" And he said, "Well, we haven't asked them yet." But it was a really great strategy, and it was fully tested if that's the one we wanted.
Yeah, that's quite a common occurrence, unfortunately. We've got to go back to the basics and look at requirements first. Right? Don't lead with technology.
It's one thing to ask the question. It's another thing to ask it in a way that the users can respond the way you want. Mm-hmm. So here we have no time for outages or weekly, monthly. Nobody has a daily anymore, but I just thought I would put that in there. Okay. And the last one we have, which features are you using for high availability today? Between the usual choices here.
This one I'm really interested in to see how the acceptance of pacemaker support, which is currently available on integrated clustering as well as for HADR.
Well, there you have it. Nothing on pacemaker, but they got 22% on pure scale. Everybody puts in HADR. It's so easy to do.
Yeah.
And TSA and the other is not sure. So that pretty well ties things up there. So with that in mind, I wanted to see if I could, I guess I had to move away from that picture. I was just going to say I went to a briefing last week in Stuttgart with IBM, and they came up. It turned out we were there at the exact same time as the Stuttgart Beer Festival. This is a spring festival, not to be confused with Oktoberfest in the fall, which is at the end of September. But they had these little beers. This was a small personal size beer. And,
looks like a 1 liter lunch.
It is a 1 liter lunch, and believe it or not, those go down a lot easier than you think, particularly when you walk on a nice warm spring day over to the facility 45 minutes from our hotel. So by the time I got there, I was just replacing bodily fluids. I was going to drink to a few of my friends, but I realized with these size of beers, I drank to everybody. So we had a real good time. There's Michael Tiefenbacher, another past speaker on the Db2 Night Show that we'll no doubt at some point have back. But boy, we had a bit of fun at the end of 3 days of good learning from IBM. And thank Roland Schock for setting that up. It was just a really delightful time. So that's the one thing I will say is that air travel has never been a lot of fun when you're going through airport security and other things, but it's not getting any better.
Sure.
All right, Dale, I'll turn the things over to you. I will stay online and I'll mute myself, but follow the question queue. So when you're ready, you just take that over, and we'll be all set to go. I'm seeing your screen. You're
okay.
And now you're in what I would call getting ready, as opposed to you've got your notes page up. Oh, it's got the next slide on the right there.
Oh, I'm showing the wrong screen. It's not full screen.
Well, the presentation's on the left, and you and your fine picture of who you are is on the right. So you can probably make that a little bigger if you know how to do that.
Yeah, I'm supposed to be broadcasting screen 1.
Okay.
Let's see, try, how's this? Is that better?
Yes, perfect.
Okay.
Great.
Somehow webinar has moved my screen numbers around. Okay, well, thank you very much, Martin. So what we're going to do today is talk about a topic that's near and dear to my heart, which is really availability and resiliency. Just to give you an idea, let me go here. Who I am, I've been around a long time, as you can see from the gray hair. This June will be 35 years with IBM, primarily dealing with availability and resiliency in the Db2 development area, but I've also involved with a lot of other things like the Academy of Technology, which has been rebranded to the Open Innovation Community, as well as involved with IDUG for the last 20 plus years. What we're going to talk about today, and I'm hoping to get through all my slides. If I don't worry about it. We'll make sure that you get a copy, is go over some basic definitions. Because one of the challenges I find when I'm going into clients is the sales team will come up and say, well, we need this technology, or we need to implement this. I said, no, that's the wrong approach. We need to understand what the requirements are first. Once we get the requirements, then we can determine what is the appropriate technology. So we have to start. And sometimes, unfortunately, our customers don't understand what their requirements are until you pose those questions, right? So you say, okay, what is high availability? Because there's a difference between high availability and disaster recovery. HA is typically localized to a single site, maybe planned, maybe unplanned, typically temporary in nature. So this is a NIC card failure, a switch failure, power supply failure. It's something that's intermittent, temporary, and typically fairly well isolated. Whereas for disaster recovery, it's typically long-term in nature and affecting more than one system. And people try to combine HA and DR together, and it's the wrong thing to do. You have different requirements. Typically for a HA environment, there's an expectation of 0 data loss. For a DR scenario, typically there is data loss that is accepted in most cases. And I'll show you one later where we had a customer who needed a system that had 0 data loss for DR, and we were able to address that. And DR is always unplanned, okay? So once you understand the difference between HA and DR, then you go into the requirements, and that's where we get things like, what is my recovery time objective? How fast do I need to get the system up and running? And I don't care how fast the database comes up, that's irrelevant. It's how fast the service to my end users come up. That's what I should be measuring. The fact that the database is up in 15 seconds, but the service requires WebSphere to be rebooted and reinitialize all the JVMs, doesn't matter. The end user sees the time from start to end. So don't think of it as just database availability, think of it as service availability, right? So once you understand your RTO, and typically HA has a lower RTO than DR, then we look at the RPO. So that's our recovery point objective. How much data can we afford to lose? Now, for an HA scenario, that answer should be 0. There is no reason in today's technology for you to have any data loss when you have a single component failure. If you have cascading failures, then that's a different scenario. That's typically more into a DR scenario where, yes, there may be the potential for data loss, and you have to find out what is acceptable. Now, we're talking about data loss, we're talking about recovery time objective, but this all talks about downtime, right? So how much downtime is really acceptable? And it's not uncommon for me to go in and talk to C-level executives and say, we need 5 nines or we need 6 nines. Unfortunately, they don't understand what that means at their level, right? When you talk about 5 nines availability, you're talking about 5 minutes of downtime per year. And that's for hardware upgrades, software upgrades, patches, security patches, it doesn't matter. So one of the key things that we have to take a look at is say, okay, how much can I afford downtime before it negatively impacts my business? One of the things that one of our old lab directors told me once was, it takes you months and months to build the trust with a client, but you can lose that trust and lose that client in minutes, okay? Especially nowadays with social media. If you see a system, you're trying to place an order for something and that system is down, then you move on to another system, and guess what? You may not go back to that vendor ever again because you've switched. You had a bad experience and there's no incentive for you to go down, for you to go back. Most customers think of it as 4 nines is typically acceptable. That's a bit dated. It's 2013. We're seeing that grow and grow, especially with the advent of COVID, causing everything to go online, people working remote. So just really make sure that you clearly define what your availability requirements are before you start going down the path of choosing a technology to satisfy needs. Just to give you some idea of what the costs are, right? This is from 2021, and it's not uncommon for the loss per hour to be in the millions of dollars, right? I dealt with a client over US Thanksgiving, so I'm Canadian, so it's a different date for us. So Black Friday, Cyber Monday, and they were getting, over 500,000 orders per day. They set brand new records with respect to income. So if they had to take an outage during that weekend window, they literally would have lost millions and millions of dollars. We had a brand new P10 server running full out with 60 cores, and it was able to keep up with the workload coming in. And we actually started with 48 cores and increased it to 60 cores online while the system was active and orders were coming in, just so that we could keep up. And that would have been literally in excess of $10 million per hour if they would have taken an outage. Okay, so we talked about the definitions, we talked about the impact. IBM and specifically Db2 has a number of feature offerings to provide your resiliency and your availability requirements. We can start at the very lowest level, which is our integrated clustering. As of 11.5.4, we have moved away from TSA. We are moving towards pacemaker. I was kind of a little surprised by the results from Martin's poll showing nothing for pacemaker. Right now, today, it is available for shared data deployments and HADR deployments. The work to use pacemaker for DPF failovers, as well as PureScale is still in development. We're hoping to get that out, and I'll show you some timelines a little later in the presentation. But this will give you approximately 2 nines availability, fully automated shared disk, right? But again, we are moving away from, and of course, this is only available on Linux today for Pacemaker. The integrated clustering for TSA is available on AIX and Linux as well. Higher in the stack from a resiliency perspective for continuous availability is HADR or HADR. It'll give you approximately 4 nines. It has a complete redundant stack, so it doesn't matter what in the stack fails, whether it's storage, NIC, power, server, or even switch. We have a second identical copy that's kept in sync automatically. The 4 nines availability, that's only achieved if you include automation. So remember, when you get DB2, when you set up HADR is very, very efficient at moving log records. It does not automate the takeover. That's where you have to use something like TSA or Pacemaker to get that automation, to give you that failover within seconds in order to keep your service up and running. So I have a number of clients that are running HADR, assuming that the failover was automatic. It's not. You have to run either DB2 Haiku or DB2 CM in order to set up the automated clustering. And it has a different licensing model in that you pay a full PVUs for the primary, and you pay limited for, or 1 PVU, 1 core for the standby. And then for those who can't work with just 4 nines availability, and that's where the basis for our always on architecture is based on PureScale. So that's our active configuration where we're running shared data. So we have a single set of files that multiple members can access in parallel. That's done through the use of GPFS or Spectrum Scale now. It gives you the ability to do horizontal scaling. So HADR gives you vertical scaling. You can add more core and more CPU, but once you exceed the capacity of that box, you have to rehost to a new box. PureScale gives you the ability to horizontally scale, add new boxes online, take them away. So we have customers who know that they're going to be running a major campaign, that they're going to see an increase in activity, so they will pay for additional servers for X number of days to be able to handle that spike, and then once they see the spike coming down, then they will bring it back to its normal operating topology. So we'll talk more about PureScale and how it works, but it is our premier offering for resiliency. Now that was for HA. For DR, we still have people doing things like log shipping and storage-based replication. Storage-based replication is still popular because it's simple and easy. If you are doing storage-based replication, please email me. There are some caveats that you should be aware of to make sure that it's configured properly so that you don't have any potential for data corruption. So there are some things that need to be set up properly, but it is still popular in use. Logical replication, which I'm hoping to have time to touch on today, those are the IDR, things like QREP and CDC packages. Now, please note that as of 11.5, QREP and CDC are no longer included with the advanced copy of DB2. Prior editions, prior releases did include a copy for DB2 use only. As of 11.5, that was removed. So if you're using QREP or CDC and are migrating to 11.5, be aware that you're going to have to make a separate purchase. Now, because we know so many people used it, it's a very high discounted product identity or PID. So you're not going to pay a lot for it, but it is a separate purchase. Some of the challenges around logical replication, there's 2 main ones. One is DDL replication. So not all DDL is replicated. With HADR, if it's in the logs, it goes across, it's replicated and replayed. With logical replication, that's not necessarily true. We do not replicate all DDL. And the other one that you have to deal with is conflict resolution. So logical replication will be able to detect a conflict, which means updating the same row at the same time on two servers. It will not prevent it. So you have to ensure that you do something to minimize exposure. And then, of course, our most popular offering for disaster recovery is HADR. It's kind of a bipolar feature in that you can use it for HA, you can use it for DR, or you can use it for both. It doesn't matter. And that's a single partition. And then for the ultimate of resiliency, GDPC is our offering. That is essentially a pure scale cluster that's spread across two physical buildings. The key to this, to make this work, is the round trip time between data centers must be less than 120 microseconds. If you exceed that time for a complete round trip, then the impact on the applications is too high. And the reason is that every single lock request that you make has to be sent to both CFs so that we can maintain the lock. So if your node fails, we can back out the in-flight transactions. And once you get above 120 microseconds, it's just really too slow. So even though I say 60 kilometers, 42 miles, it's really doesn't matter the distance. It's all about network latency, and it's being that 120 microseconds is the key. Okay, so let's talk about pure scale. This is where I want to spend the bulk of our time. What is it? It is our shared data architecture. It is based on the Sysplex on the mainframe. It's publicly aware that the mainframe is the gold standard for availability. We are fortunate enough that we are able to entice the engineers who design Sysplex to help us design pure scale on open systems, right? And it has things like elastic capacity where you can grow and shrink horizontally. It has extreme availability. If a single member goes down, we are able to redirect the workload to the surviving members, so the applications don't even know that components have failed. Application transparency, what I mean by that is on some shared data architectures, you really need to segment the application to work on separate members so that they don't conflict with each other. We don't require that. We have an integrated load balancer that will move the workload across the cluster members based on the resource availability. So we will automatically load balance for you. Now, if you do need to have certain types of workloads isolated, so maybe you have a combination of OLTP with some reporting, you can isolate the reporting to a subset of the servers so as not to interfere with your main purpose for having the database, which is the OLTP. And we're seeing a lot of people doing workload consolidation, taking a number of different databases and putting them into a single pure scale cluster. And the perfect example is I'm working with a bank in South America. They have currently 426 MySQL databases. And what we're doing is we're consolidating those into a single pure scale cluster running on a Z15 on Z-Linux. So we've done a POC, we've done some benchmarking, proof of concept. Everything is looking really good. We're actually going to be doing the first phase of the deployment next week, where we're going to take all of these databases and bring them into a single pure scale cluster, but again, that's running on Z-Linux. And then more recently is the fact that we are going to be making and have made available TSA on the cloud. So one of the limiting factors to cloud adoption for PureScale is the integration with Tivoli System Automation for multi-platform with TSA. We currently have it available. You can roll your own with sockets only on IBM Cloud. We have an offering on AWS where you can go in and request a PureScale cluster, and within 30 minutes, a cluster will be available for you, fully configured using sockets. We will see more adoption of cloud once we replace TSA with Pacemaker. So stay tuned for that. We hope to have a beta out this year. And then once that's done, we will have the ability to deploy on any cloud. So just give you an idea of where we are and where we've come from. So PureScale was based on Z-Linux. Db2 started, it says 93. I actually started working on it in 1992 when we transferred it up from Austin, Texas to Toronto. It only ran on Db2 OS2 EE. So that shows kind of my age. Sysplex was ported to LUW in the early 2000s. We made sure that the database was fully ACID compliant, had fine-grained access control. So we wanted to take all the features and functions that were on your single partition database and deploy that in a PureScale environment. And I think we're pretty much at par with respect to features and functions. We started off with a bit of a blinders on, and we did AIX and InfiniBand only, which is kind of funny because InfiniBand is kind of gone by the wayside. We're actually not going to be supporting it. We're going to deprecate support for InfiniBand and go strictly with Rocky. Rocky was introduced in 2012. That's also when we started introducing non-AIX support, so RHEL and SLES. 2021, we introduced it on Z-Linux. That was on the Z14. 2017 was Power. So, and as of June of 2022 is when we gave you the self-manage support on AWS. So you can see that we are continuing to invest. If I were to take a look at the investment portfolio for Db2 at our lab, I'd say about a third of our resources are focusing on PureScale. I did some surveys with our clients just to see, who's using it and who's not using it and what are you using for HA. And it's just a little under 50% of the customers who have strict HA requirements are using PureScale. This number is growing. I'm probably spending more than 50% of my time on PureScale engagements, either proof of concepts, proof of technologies, or demos. So it's quite popular and growing in popularity, especially now with the Z-Linux support. With respect to geographies and who's using it, primary use is finance, right? When you have a single transaction worth $1 billion, you can't afford to lose that single transaction. Manufacturing is another one. When you're doing things like making wafers to do chips, right? If you don't track the progress of the chip down the line and know where every chip is, if you lose database connectivity, essentially those wafers have to be thrown out, and that could be millions of dollars. So we see quite a few chip manufacturers using it, and then of course government, where we're doing it. One interesting project that I worked on was on, and it took a while to get clearance to even get me involved, because it was with the US military on using PureScale within their surveillance planes, right? So they want to make sure that when they're flying over enemy territory and they're taking pictures, that they capture that data. They can't afford to have a server go down, and because they're not going to get a chance to fly over that place again. So US military and government. With respect to geographies, we're all over the world, right? North America, obviously, that's the biggest one, Asia Pacific, and we're seeing an uptake in that South America slice is going to grow and grow. So let's just talk about PureScale. What does it do? What are the components? So the first part is the automatic load balancer. So a client comes in, it connects to any one of the single nodes. When that connection comes back, you get a full list of all available members and their workload. By having the driver have a stanza in it called the enable WLB equals true, we will load balance, and we can very easily set up demos for you. I was actually working on the demo this morning where I have a PureScale cluster in IBM Cloud, and I was running my app in one window and monitoring the use on the other, and my 4-node cluster, without WLB, everything went to the node that I connected to. As soon as I put that WLB on, you can see a nice even split of the workload across all 4 members. We run on Power, we run on x86, we run on Z, and we run on EC2. So our commitment is that regardless of where you want to run, with the exception of Windows, we will have support for PureScale. Now, the secret sauce behind this is very much modeled after Sysplex, where the coupling facility or caching facilities is really a mirror image of the coupling facility on the mainframe. That's where we keep our global locks, lock list. We keep our global buffer pools, and we have something called an SCA, which is where we put things that have to be synchronized across the cluster. So things like identities and sequences are all stored in our CF, and of course that becomes a very sensitive point, very critical piece. So we have 2 that we keep in sync at all times. The cluster services today is provided through TSA. That work is underway to replace that with Pacemaker so that we can remove the dependency on it. We do require a high-speed interconnect between the members and CFs. We do recommend that this be on a dedicated network, so dedicated switches just for PureScale, because PureScale is very sensitive to latency, and if it has to deal with other traffic on the switch, then it has a direct impact on the performance and throughput. So we do recommend as a best practice to use it dedicated switches. Now, for non-prod, TCP/IP sockets is fine, but for production, we do recommend an RDMA type deployment. An RDMA requires things like the Mellanox CX4, 5, or 6 adapters that support Rocky, which is RDMA over Converged Ethernet. And then, of course, the last component of PureScale is the Spectrum Scale, which is our shared data. What's nice about this is that every member has access to all of the data and all of the log streams. So they each think that they're running independently and have access to the files, but it's Spectrum Scale that does the coordination of the writes. And because the logs, transaction logs, are on the shared data, if a member does happen to go down, a surviving member will have access to those transaction logs and be able to very quickly, typically under 30 seconds, back out any in-flight transactions. And that would be transparent to the application. So, as I stated again earlier, we have the ability to do this horizontal scaling, grow as you need capacity, and shrink as you need capacity as a full online operation. And we're scaling nearly linearly. If you go from 1 member to 4 members, you're getting a 3.9x. If you go up to 8 members, you're getting 7.6 times as much throughput. If you go all the way up to 12 members, we see up to 10. Typically, a typical cluster is between 3 and 8. We don't see too many going beyond that. especially with the hardware that's available today. The machines are so beefy and so powerful that you don't need a lot of physical servers in order to do your workload. So the sweet spot seems to be 3 to 8 is the most popular type of deployment model. But we do scale all the way up to 128, right? So you can go to the extremes if you want to, but not too many people are going that far. PureScale does handle things like unplanned outages. So if a server does happen to crash for any reason, then we will redistribute the transaction. So here we have our workload balancer coming in, bringing in the workload to all 4 members. If a member goes down, not a problem. It'll go back to the client. The client has a list of all of the members that are available, and it will redirect that traffic. Typically, in most cases, we'll actually even reissue the SQL. There are some exceptions. So if you had a global cursor, an open cursor or a global variable, then those would not be available on the surviving members. But for the most part, the transactions will be reissued on the surviving member, and your application would not have any idea. Meanwhile, that server is down, you can take it out, you can do your maintenance on it. Once the maintenance is fixed, be it hardware or software, you bring it back into the cluster, and we will automatically recognize that it's there and automatically start sending work to it. So you don't have to do anything. The applications are completely transparent to them that the cluster went from 4 nodes down to 3, then back to 4. All they'll see is more throughput, faster response. You can also do the same type of approach for planned outages, whether you're running Db2 fix packs or if you're running hardware updates or you just need to do some sort of administration. We can identify which member that you need to do the maintenance on. We can take that member out of the cluster and do the maintenance on it and then bring it back in. So much like the unplanned where you didn't schedule it. With the planned outages, what's nice about it is that you identify the member, you say, take it out of the load balancer, but let all the work that is currently running complete normally. So not a single transaction is rolled back. We wait until all the work completes, and then we allow the member to continue on. New in 11.5.7 and 5.8 is the ability to do work on multiple hosts at the same time. So long as you have 50% plus 1 of the cluster entities available, CFs and members, then we're able to do maintenance. So it just allows you to be a little more efficient, and we are actually smart enough to know determine what the hardware layout is, and we will figure out which ones we can take offline. So obviously, if you had the CFs on node 1 and 2, we could never take both of those nodes down at the same time because we wouldn't have a CF available. No CF means no PureScale. So we have intelligence to figure out which nodes we can take down and when we have to bring them back up. From a client perspective, right? The default is you'll run where you're connected, but we have the ability to do other models. So you can do client affinity, where you can say, this workload, so let's say reporting, I only want to run on member 1. And replication, I only want to run on member 2. And OLTP, I only want to run on member 3. And that's very easily done through a standard db2 dsdriver.cfg file. And I have lots of samples that I can share with you on how we can figure this out. Or you could say, you know what, I just want to get the best performance available, just distribute the workload as evenly as possible. And this works well, even if you're doing things like changing hardware. So we had some customers go from P8s to P9s. Well, they would roll them in one at a time. And even though that P9 had more resources, the load balancer was aware, and it would send more work there than the P8s because it had more resource. So it'll load balance based on resource utilization. And then automatic client reroute, that's where if a member does go down, we will ensure that it's automatically connected. And again, those are controlled by things like your DB2 DS driver or your DB2 CLI.ini files. And again, we have lots of samples. PureScale does provide HA, right? Each of the physical members must be connected to the same physical switch in order for you to get PureScale to work. It does not provide disaster recovery. It's an HA solution. So you have to combine it with other technologies for DR. So things like Hatter will work with PureScale. The only restriction is you have to have the same number of members on both sides. We have customers doing storage-based replication for DR on a PureScale environment, as well as CDC and QRUT. And then the last one, of course, is what we talked about earlier, which was the GDPC, which is the stretch cluster. So just remember, when you're looking at PureScale and you're going to do a deployment, don't forget DR. You have to set that up as well. IBM and Michael Kwok and his team is very committed to PureScale. This is just a laundry list of some of the big things that we have done over the last few years. We've spent time looking at what we can do to improve security. So we put in the firewall ranges. We've added the online add and drop of members and CFs, multi-tenancy, EHL support. We look at how we can make a recovery faster. So when a member does go down, how do we bring it online quicker? We've made the installation and the monitoring much easier. We've enhanced DB2 cluster with a bunch of verify options so that you can go in and validate the topology and the networking before you actually do the deployment. So the lab is very committed to PureScale, and again, this is just a laundry list of items that we've implemented. We are very committed as well as a hybrid cloud company to making sure that what we have is supported in clouds. So we do have support for this in AWS as bringing your own license, and as well as IBM Cloud on certain types of operating systems. Late last year, we added HADR support for PureScale. We're hoping to get this RHEL 9X, that's not 2022, that's a future item. That's we're looking at doing things like getting RDMA or the equivalent of RDMA support in the cloud, bringing up the operating system, so RHEL 9. Right now I'm running everything on RHEL 8.6. When you go to PureScale on AWS, we have a bunch of t-shirt sizes. You just choose whichever one that you need based on your sizing. If you don't know how much resources you need, contact me directly. I will help you size the environment. We have spreadsheets that we ask a bunch of questions: transactions per second, complexity of the workload, read to write ratios. And once we have that information, then we can give you a fairly good idea of how big a cluster that you need. So we are committed to running on-prem, on the cloud, on Power, on Intel, and on Z. Just to give you a smattering of where we are today. So we have support for AIX 7.2, 7.3, RHEL 7.9, 8.4. I'm actually running it on 8.6. We have Z-Linux. Z-Linux is restricted to these two operating systems only, which would be 8.6 for Z15, 7.7 for Z14. We support IBM Power VM. The LPARS is our preferred choice. We do support VMware, KVM. We are working on ZVM now. That's work is under development. So another roadmap chart just showing, reiterating the RHEL support with post 11.5.8, which will be our next mod pack. We are hoping to get pacemaker support as a beta for PureScale. And then Z16 support. So right now it's only 14 and 15. Next year, end of this year, possibly early next year, we'll get at the pacemaker GA support, probably in the 2024 timeframe. So I'll update these slides, and then the CX4 or CX6 support for Mellanox adapters will be coming. Okay, so I only got about 10 minutes left. I've done talks on HADR and PureScale in the past on the night show. So let me just skip down. You'll get a copy of these, so you don't have to worry about trying to read things as I skip through. What I want to do is take a look at some things that customers are actually deploying. So one of our accounts came to me and said, look, we need to be able to have zero data loss DR. My immediate thought was that, well, that's, you know, that's not going to be possible. We can't break the speed of light yet. We're working really hard to do it, but it's not possible. I said, okay, these are my requirements. I need provide continuous availability. I need zero data loss DR. And by the way, I have a bunker site that you can exploit. I said, oh, okay, well, that changes things. So what they had was, and this is for an airline, they had HADR set up in their primary data center. And then they had their remote data center for DR out of state, and they had super racing. But they said, you know, we really cannot afford, we don't care if we're down for 10 minutes, we just can't afford to lose a single transaction. So the scheme that we come up with was taking and doing full synchronous replication of the transaction logs to the bunker site. And then as part of their DR, because they knew that in Charlotte, they didn't have all the data, right? Because it's super racing. They would copy the transaction logs from the bunker site to the DR site before activating the database. So this was able to give them, assuming that Zebulon and Wilson did not go down at the same time, that they could get zero data loss, but they accepted the fact that their RTO would be higher, right? And this worked for them. Another customer said, we want continuous availability. Our workload is mostly read. There's very few writes, and we need to be able to have it available at all times. And this was to process logins for web applications on a bank. So I partnered with our ISAM appliance team, and we've come up with an architecture where we use the set of LTMs so that we could load balance within each data center, and then they use the LTM to direct, or the ISAM appliance was only able to catalog 2 entries, right? Which database I was going to talk to, either database A or database B. And that doesn't work well for PureScale because each database had multiple members. So we had to say, oh, how can I separate and make each database look unique? And we did that through the LTM. And what we found was once you connect it through the LTM and connect it to a member, the LTM comes out of the picture, and it's a direct connect between the ISAM appliance and the member. Load balancing kicks in, and it does all its good stuff. So the LTM was really there only to say this side is active or this side is not. This worked really, really well, mainly because there's very few updates. You don't change your web banking login very often, but it does give you that high availability. So they could have component failures or site failures, and with the use of QREP to make sure that any updates got sent to both. And this has been up and running now for 5 years, a little over 5 years. We've had this in production with zero downtime. So it's been very, very well. Last one I want to talk about was another system where we wanted to provide continuous availability, but also provide zero downtime when doing upgrades. This is another financial sector where they're doing bank clearing of checks, right? So you deal with, say, TD, and you go to a BMO and you cash a check, and they want to be able to validate that you have the funds. In the US, that's done electronically, and the bank receiving the check sends a request off to your home bank, and your home bank has about a 20-second time to respond back. If it doesn't respond within that 20-second window, then the bank with the check allows it to go through. If for any reason that check bounce, the bank where you wrote the check on has to pay a penalty, because they expect a acknowledgement within that 20-second window, and if that doesn't come in, then that bank is liable. So this was a bit of a complicated scenario. So we put in PureScale across 2 different floors on their data center to give them the ability to have near continuous availability within that PureScale cluster. And I said, okay, how are we going to handle software upgrades, right? Because especially things like schema changes are not handled by PureScale because it's changing the actual application. So what we did is we set up a sandbox environment, identical, and we used a QRUP between the 2. So what they would do is they would run on the left side. On the right side, they would introduce a new version of the application. They would do all their testing, and then once they were ready to deploy it, they just moved the production workload from one side to the other with zero downtime. They just redirected the traffic. And they would ping pong back and forth based on the development cycle. But they also needed DR, right? Because this provides HA, this is all within one data center. So again, we did HADR between them. And then of course, with DR, remember I stated earlier, if you do find a situation where a disaster occurs, you're typically failing over for an extended period of time, then we also set up unidirectional QRUP between them so that if they did fail over to the DR data center, it was a full mirror of production. Okay, this was an exciting one. This deployment took us several months to get an agreement and to get all the parties in line, but it worked out very, very, very well. So I've got 2 minutes left. What I'm going to do is I only had one more scenario. I'm going to skip over it and see if you have any questions before we run out of time. So thank you very much for listening.
Great job, Dale. It's always great to have you and get the update. I'm just noticing that we have no questions in the queue, but let me just take control back here and,
Sure.
and just to wind up and
okay.
Get my ducks back in a row.
Yeah.
Where are my ducks? They're running around again.
They're probably in my pool, which really annoys the jeepers out of me.
Oh yes, yeah. I remember being on the road one day, and my dear wife was telling me that with the solar blanket on, the ducks were there were some baby ducks swimming back and forth under the cover, and I saw this as a really good sight gag, but she saw it as a real annoyance, and she did not appreciate me chortling into the phone about the cute little duckies. But we've
so I got a couple of updates to make to the presentation, Martin. I'll make those and I'll send it out to you later on.
Perfect. Thank you so much. We always appreciate getting the handout from our speakers. So with that, let me ask our final polling question. And whoops, wrong one. There. Which one is it? What does this button do? There we are. Did you learn anything today? And,
oh, I hope so.
Oh yes, it's always good when they do. And I'm confident that we will have no trouble getting people to say that or share that with us. When the answer is 100% of people did learn something. So life is good. Life is good.
Life is very good. And again, my contact information will be in the slide deck that Martin's going to post. My my area covering for DB2 is the Americas. If you happen to be in Europe, contact me and I'll put you in touch with somebody local. So
Great. That's good to know too. All right. With that, I'm going to cue the music. Thank you once again, or several times before we end. I'm just going to turn up the volume on this. And there's our famous theme music going. With that, thanks again, Dale. Everybody have a great weekend, and we'll see you next week for our Z show with Dale Belke on the DB2 Night Show. Thanks again, and bye-bye.
Bye-bye.
Thanks, Dale.
Thank you.